Over here. Over here. Say hi, Briscoe. Hi, Briscoe. This is my big dog. My big mean dog. Growling at you. Growling at you. Just kidding. Yeah, you're a good puppy dog. Oh, my God. You're huge. You're so huge. Right, buddy? You don't lick me. Don't lick me. Anyway, Briscoe says, good luck on your Regents exam. And goodbye. Bye, buddy. Go upstairs. Anya. All right, that's it, kids. If you stay down here, all you do is hear me yell at him. Woo! I'm just kidding. I love my doggies. He's my cute doggy. So he gets to go upstairs. And we get to work on Common Core Algebra 1, August 2015. If you're here, I'm here. We're both here. And we're here to do parts 2 through 4. Oh, the extended response questions. They get a little crazy with the extended response questions. The multiple choice aren't too bad, but the extended response questions are a little bit weird. Anyway, they're not too bad. All of this stuff can be found at my website, www.mrkrausemath.com. By the way, I should probably show you what this looks like, because some people don't even know. You know, you can go over here. Let's see. Oh, there's my site right there. It's got my stuff on there for my kids, what they're doing over spring break. Oh my God, Mr. Krause was the hero. He assigned homework over spring break. Everybody's excited. Anyway, this is my website. Shh, you know you're at the right place. That's a video you might want to watch. It's about bullying. It's about a little kid that can sing like crazy, but it's about bullying. So there it is. And then if you come over here to Regents Review and you click on Common Core, you'll notice that I have the exam. There's the exam. It eventually pops up. I have the multiple choice answers. So you can come over here and grab the multiple choice answers. Don't just copy them. That's stupid. Okay, they're there for you to look to see what you did right or wrong. And then the 3 video parts right here, all organized for you. And I'm not quite done. I'll be done with these by the end of the week. Notice I'm finishing up this one right here. This is the one I'm working on right here. Nope, right here's the one I'm working on right now. That's the one we're doing right now. You'll see that one. And then we'll work on these other ones. Anyway, let's get out of that and let's get back to work. I think we're going to page 12. Oh my God, I'm so good. Anyway, here we go. I think I figured out why that doesn't work. Oh my gosh, that's awesome. So each day, Tony, with an I, Tony, records the high temperature of plants in her science lab. Her data is our table below. The plant continues to grow at a constant daily rate. Write an equation to represent h of n for the nth day. Now, I'm going to do this 2 different ways. I'm going to do it the sort of practical way, and then I'm going to do it a little bit harder way. So the easiest way to figure this out would be to figure out that the common change here is 1.5. So therefore, my slope is 1.5. I don't really have to do a lot of work there. So what I have here is y equals mx plus b. I take the 1.5 and I put it in here and I get y equals 1.5x plus, and I need the y-intercept. Well, the y-intercept is on day 0. What happened on day 0? What would be my y-intercept? So what we'll do is we'll go in this direction, 1.5, and then my y-intercept to just be 1.5 because 3.0 minus 1.5 is 1.5. So there's the answer to the equation. So that's method 1, how to solve the question. Now method 2 is a little bit, well, a lot more difficult. So the first thing you do with method 2 is find the slope, and that's not too bad. You just take 4.5, you subtract off 3, and you take 2, and you subtract off 1, and you get 1.5. So finding the slope, again, is not difficult. But then you have to pick a point. It really doesn't matter which point we pick. Let's pick that one. It'll all turn out to be the same. And we use this equation, y minus y1 equals slope x minus x1. So I could get y minus 6 is equal to 1.5 x minus 3. If I bring the 1, I get y equals 1.5 x minus 3 plus 6. Now, having said that, That, by the way, is an acceptable answer. You can take that answer in. I'll show you the other answers that could be acceptable as well. But when I'm doing this, I could do, if I distribute that 1.5, I get 1.5 times x is 1.5x. 1.5 times negative 3 is minus 1.5. Oh, no, it's not. 1.5 times negative 3 is negative 4.5. And then plus 6, and I end up with y equals 1.5x plus 1.5. Mine was a little bit easier. By the way, this was a completely acceptable answer. The other acceptable answers could have been y equals 1.5 x minus 1 plus 3, y equals 1.5 x minus 2 plus 4.5. You get the picture, right? You get the picture? All right. So any one of those where this would be the vertex or the point that they give you. Okay, let's move on. I've got to graph this thing. Before I graph it, let me just blow it up a little bit. I'm going to solve for y, so I'm going to bring this 2x over. And when I bring 2x over, you know what I like to do? I like to drink me a little bit of Java from Dunkin' Donuts Loves of Rochester. They don't love me because they haven't given me any money, but I don't care. I still drink your coffee. Sometimes it's Dunkin' Donuts K-Cups. Sometimes it's just Dunkin' Donuts. All right, so there it is. So my slope is negative 2 over 1, and my y-intercept is simply 0, 1. I'll plot that here. 0, 1 is my y-intercept, and my slope says go down 2 to the right 1, 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 and I'm going to go the opposite direction. Come on. Sometimes it doesn't like me. Up to, up to, up to, up to. Now, you have to decide whether or not you're going to get a solid or dotted line. This is a strictly greater than. Because it's strictly greater than, and this is only a 2-point question, you want dotted. So we'll put an arrow here. We'll do dotted. Now, you need to use a straight edge. I cannot use a straight edge on this screen and the method that I do this with. There you go, it worked. So you have to use a straight edge and do your dotted line along that straight edge, make it look professional. You're still not done because this says greater than. So I have to figure out which way I'm going to shade, and shading is going to be greater than things go up, so we'll shade up. And there she is, kids. Is that it? That's the end of that problem. All right, moving on. Page 14. Oh, my goodness. Rachel and Mark were given the following information shown about the bacteria in a petri dish in their biology class. Now, it's a biology class, so I'm going to tend to believe Rachel, just because I'm a little... The model of this information to be linear. Mark wants it to be exponential. Which model is the best choice and why? Okay. So, Rachel wants linear. Rachel wants linear. By the way, Rachel is going to be found to be wrong just by glancing at the table. In order for it to be a linear function, we have to have a consistent slope. Your teachers won't like the word slope, so we'll use consistent rate of change. So if we have a consistent rate of change or consistent slope, then Rachel's correct. So let's check this out. Let's do some examples. So we'll do 280 minus 240 over 2 minus 1, just using these 2 points. And I get 40 over 1, or 40. So my rate of change there is 40. Now I'm going to pick some new points. I'm going to pick Let's try these points. Let's just see what we get with these. Again, it's consistent all the way up. So in example 1, now we're doing example 2. So we're going to do 690 minus 550 over 6 minus 1, or 5, which is still 1. So 1, and this is 690 minus 550. That's 140 over 1. That's 5.5 times as much. Let's just do one more just to see if this gets crazy. Because if it gets crazy, then you should guarantee it's exponential. 1680, 1340. So 1680 minus 1340 over, was it 10 minus 1? 10 minus 9. 10 minus 9. And this is 1, and this numerator is now 340. So 340. So the answer is Mark is clearly the better biology/math student because an exponential model is the better fit for this data. Now, although I've had fun with this and I've had a good time with it, I still haven't answered why. I've done the math over here, but I haven't explained why. So the last thing you got to do is explain why. The reason a linear model is no good is because there is not a consistent rate of change. Something to that effect, children. All right? Anytime you're looking for a linear model, you're looking for a consistent rate of change. In this case, it was not consistent. A driver leaves home for a business trip and drives at a constant rate of 60 miles per hour. For 2 hours. Her car gets a flat tire and she spends 30 minutes changing the tire. Should have called AAA, would have taken 4 hours. She resumes driving and drives at 30 miles per hour for the remaining 1 hour until she reaches her destination. Now, what is she afraid she put the tire on there wrong? Why would you slow down so much? On the set of axes below, graph the model of the driver's distance from home. So let's talk about this. She's driving for 2 hours at 60 miles per hour. Then for a half an hour, nothing, no movement. And then for another hour, she drives at 30 miles per hour. So this should be steep, this should be nothing, and this should be shallower or not quite as steep. So she starts at home. Now notice the y-axis is my distance from home. So my y-axis is my distance in miles from home. So when I start this thing, I'm starting at home. And I want to drive at 60 miles per hour. So 60 miles in 1 hour. And I did that for 2 hours. So I want to go for another 60 miles. And then splat! Flat tire time. And see, my distance from home is not going to change. So for the next half an hour, I'm going to stay stagnant, not going anywhere, not changing my distance. And then I get my tire changed. Now for the next hour, now be careful, we're at 2.5 hours. We're going to go to 3.5 hours. I want to drive at 30 miles per hour. Well, this is 120, that's 150, that's 180. So for 30 miles for the next hour, so over the next hour, I'm going to drive 30 miles per hour. And that's how long the trip takes, and that's where it's got to end, kids. You can't go any further than that. You can't have any arrows. It's got to end there. That's it. That's all she wrote. That's the end of the story. That's it. It was awesome. Next, there's a really crazy problem on this test, by the way. So how many real solutions does this equation have? So the first thing I tried to do was factor it. It is not factorable. So the question says, how many real solutions does it have? So this test decided it was going to test the quadratic formula or completing the square. So I'm going to do this one by completing the square and the quadratic formula, just because I'm not sure what you guys are comfortable with. So I'll do it both ways. So x squared plus, x squared minus 2x plus 5 equals 0. So that, by completing the square, it's x squared minus 2x plus square equals negative 5 plus square. Now the negative 5, because you got to toss that over here. So now I'm going to factor this sucker. Now, for completing the square, you take half of this and put it in here. Well, half of this is negative 1. Square it, I get 1. Square this, I get 1. So what I end up on this side is negative 4. Oh, God, these people had to be jerks to you all. I am so sorry. So this is going to give me x minus 1 squared equals negative 4. Now, the next step in completing the square is to take the square root of both sides. Don't forget to put a plus or minus. So on this side, I get x minus 1 is equal to the square root of negative 4. It looks like you can take the square root of it, but you should know at this point you're not allowed to take the square root of negative 4. If you have a high-powered teacher, your teacher might have told you the answer to this is 2i. I stands for imaginary answers. But you are not allowed to take, in 9th grade, the square root of negative 4. You get imaginary roots. So the answer to this question is 0. There are no real solutions. Now, having done it that way, I'm going to show you how I do it using the quadratic formula as well. So we'll just ignore that. And I write down A is 1, B is negative 2, C is 5, and I also do D. Now, for me, D stands for discriminant. And D is B squared minus 4AC. And I like to do the work right here. B squared is 4 minus 4 times 1 times 5. Well, this turns out to be negative 16. So when I go to do the quadratic formula, I get x equals negative b, 2, over 2 times 1, which is just 2, plus or minus the square root. Now, in here goes the discriminant, b squared minus 4ac, but I've already done that math. It's negative 16 over 2 times 1. As soon as you have a negative discriminant, you know your answers are imaginary. So, your answer to this question is, there are no real solutions to this equation. All right, kids. What's that, 29? I'm going to stop at the multiple choice at the end of the 2s and just keep going, then come back. So, because I've been having video problems, so let's see if I can fix it that way. A number of carbon atoms in a fossil is given by the equation 5,100 times 0.95 to the x, where x represents the number of years since being discovered. What percentage change What is the percent change each year? Explain how you arrived at your solution. So I'm going to explain this using math. You should know the equation y equals a sub 0, 1 plus or minus the percentage to the time. So in here, a plus means growth, which means a number bigger than, not equal to. In order for it to be growth, it has to be larger than 1. And a minus means decay. And that means a number less than 1. Well, in this case, our starting amount was 5,100, but that really doesn't make any difference. What we really want to take into consideration is this. Let me rewrite this. Y equals 5,100. This is my starting amount. 0.95 to the x. Now, since this is less than 1, so since 0.95 is less than 1, it is decay. And how much less than 1? Well, isn't that 1 minus 0.05 or 5% change yearly? So there's your answer, 5% change yearly. Because 1 minus 0.05, which is 5%, gives us our 0.95. So it's a decay of 5%. All right, 31. 31. Another 2-point question. A toy rocket is launched from the ground. A toy rocket is launched from the ground straight upwards. The height of the rocket above the ground is given by this equation. You'll find out when you take physics why they like -16 so much. T squared plus 64t. Determine the domain for this function. So first of all, you got to understand what is going on here. And for those of you who like to launch rockets, by the way, don't do it anyplace. It goes up, 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 and then down, top, 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 down. So at this point, y equals 0. And at this point, y equals 0. So that's the domain. How much did it go from here to here? Well, I know my domain should be starting at 0 and going to something. I'm just not sure what it should be. So what we need to do is find the root. So the simple way to do this is just factor this thing and find the root. So -16t squared plus 64t equals 0. We'll factor out the GCF, and in this case, the GCF, believe it or not, is -16t. Well, let's say you didn't take out the negative. 16t, it's t, it would be, if you didn't take out the negative, then it would be -t plus 4 equals 0. Now we're going to take each of those and set those equal to 0. So 16t equals 0. Well, clearly t equals 0. We've already determined that that would make sense. And then we're going to take this one, -t plus 4 equals 0. And if I bring the t over, whatever, I get t equals 4. So my domain should be 0 to 4. Now that's an explanation mathematically. Determine the domain, explain your reasoning. Now, if you didn't like doing it this way, you could have clearly done it this way. You could have come over here and graphed it. You could have said, okay, -16, you got to use x squared plus 64x, enter. And there it is. Now, it's hard to see, but up there somewhere is the max. But here's my roots at 0 and 4. So you could have gone through an explanation at y equals 0 when x equals 4, used a calculator to determine the roots, and it arrives back on the ground after 4 seconds. So the answer to the question is 0 to 4. Next question, 32. Jackson is starting an exercise program. The first day, he'll spend 30 minutes on a treadmill. He'll increase his time on the treadmill by 2 minutes each day. Write an equation, T of D, for the time in minutes for the treadmill on the day. All right, so this is another one of those. I've seen it almost in every single solitary Regents exam now. My time per day. Well, the first day, I'm going to spend 30 minutes. Then every other day, right? In the last test, it was every other gigabyte. And then the other one was every other minute. I'm going to add 2 minutes. So my change is 2 minutes per day. So I've got to add 2 minutes, but not to include day one. Day one is right here. And this one will be D minus 1. So this is one of those, this is the answer, by the way. This is one of those, you do something once, but then for everything else, we're going to do it that way. It's always going to have this parentheses minus 1. And you'll see it come up over and over and over again. I think it's been almost every Regents now. All right. And now I just want to find out T6. So I'll just say, okay, T of 6 is equal to 30 plus 2 times 6 minus 1, which is equal to 30 plus 2 times 5, which is equal to 40 minutes. So you'll spend 40 minutes on the treadmill. Done. All right, I'm going to stop there. I'll come right back. Dunkin' Donuts coffee, baby. Yeah, boys. Anyway, here we go. I had to take a little break. Didn't even know I took a break, probably because I'm that good. Let me just make sure I'm writing. Okay, so I have to graph f of x equals x squared. And then I also have to graph g of x equals 2 to the x. So let me get a table of values for these. I'll do this one. I think it looks like they want us to graph for x is greater than 0. So let me see how high this is. 1, 2, 3, 4, 5. I just want to know how high I should go. 6, 7, 8, 9, 10. Cortana comes on while I'm counting. How dumb is that? 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 looks as high as I want to go. I don't know what I want to do with my x-axis. We'll see. Maybe I'll get rid of those. X and g of x. So let's see. 0, 1, 2, 3, 4. And I don't think we're going to get to 5. So 0, anything raised to the 0 power is 1. Now, if you don't believe me, you come over here and you say, okay, get rid of this. I want to graph 2 raised to the x power. Now, again, I don't really care about any of this. I'm going to go to 20. So I want to be able to get 20 on my graph. There, somewhere there. So I want it like this. And I can go to my table, Control T. And there's 0, 1. 0, 1. I can come back over here. 2, 4, 8, 16. I don't know why I can't get back on my graph here. Oops. There I am. That was fun. So I can go to the table and go 2, 4, 8, 16. And this one would be 32. So that's off the graph. So let's graph it. Oh, wait, hold on. I want to see what my other table is going to look like. So let's go over there. Let's graph this one. Let's see what this one's going to look like. I don't know why these random things keep popping up. X and Y. Go back over here. I'm going to hit Control T to get rid of that. And then I'm going to do Tab. And then we'll do X squared. Oops. X. Come on, Mo. All right, X squared, and we'll get that. That's an interesting one. So let's see what's going on here. See how it's got a little bit of separation there? I really don't like that. So I'm going to go into Menu, Windows, and Zoom 4, and I'm going to go to my Windows settings. Now my X min, I want to go from 0 to looks like 4. So I only want to go X to 0 to 4. But my y, I want to go from like 0 to, let's go up to like 24, something like that. I think we'll get a better window of what's going on. You see how the blue's on top and then the red takes over, but eventually it goes back on top maybe? Weird. So I could go to the table, but I'm not. 0, 1, 2, 3, 4, 5. I can square things. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So I want to graph these things. Let me graph the blue one first. So now I only have to get to 4. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to make every 2 1 just to kind of spread it out a little bit. 3 and 4, and I can't get to quite the 5 yet. So 0, 0 for blue, and then 1, 1, 2, 4, 3, 9, and 4, 16. So that's what this one is going to look like. And I'll switch to purple. 0, 1, 1, 2. Notice this one's on top. 3, no, 2, 4. Uh-oh, they cross there. Point of intersection. 3, 8. It's below. 4, 16. We're back. So the purple one does something like this. It goes under for a little while, but because it's an exponential, it's going to grow a lot faster and go like that. Wow. Whew, tough problem. State which function f of x or g of x has a greater value when x equals 20. Well, the purple one is going to, because it's an exponential function. So g of x will have a greater value at x equals 20 because it is an exponential function and it grows faster than a quadratic function. F of 20 would equal 400. I don't even know what 2 to the 20th is. 2 raised to 20th, this is going to be somewhere around my salary, is 1 million. G of 20 is equal to 1,048,576. There you go. Something to that effect, kids. Moving on. Ching, ching, ching. Solve algebraically. Solve algebraically means you're not allowed to graph it. You have to solve this algebraically. So let's do this. 7x minus 12x plus 24 is less than or equal to, now let's combine things. This is negative 3x plus 12. All right, let's start. No, let's combine things. We still combine things. This is negative 5x plus 24 is less than or equal to negative 3x plus 12. I never, ever, ever like having my x is negative or my x squared is negative especially. So I'm going to bring this over. So I get 24 is less than or equal to 2x plus 12. Now I'm going to bring the 12 over. So I'm going to subtract 12, and I get 12 is less than or equal to 2x. Divide by 2, and I get x is greater than or equal to 6. I don't really like the way this looks. I really like looking at it like this. I think it looks better. X greater than or equal to 6. Notice they mean the same things. Notice the greater than thing is pointing towards the x. So if x is a number in the interval from 4 to x, remember we've got our total is x is greater than or equal to 6. State all integers that satisfies the given inequalities. Now remember, this represents 4, 5, 6, 7, and 8. So my answers is going to be all the numbers greater than or equal to 6. 6, 7, and 8. Now, explain how you determine these values. I chose all values. Greater than or equal to 6. My pen tip's going. I gotta change it up a little bit. Boom, something like that. Boom, moving on. Boom, shakalaka. We got 3 problems left, 35, 36, and 37. The volume of a large can of tuna fish. Could they have picked something better? Now, I have no sense of smell, and I can't taste anything, but man, tuna fish, man, that's some ripe stuff. It's good for you, though. It's supposed to be good for you. Volume is equal to pi r squared h. Now, I'm going to erase this r squared. I'm going to put it in red or orange or whatever color comes up. Orange. R squared. So it wants you to solve for the radius. So what I need to do is get that radius all by itself. So I'm going to divide by the things I don't care about, pi over h. If I divide the right side by pi over h, I got to divide the left side by pi over h. You get it? Man, you guys are smart. Those go. See ya. So I end up with r squared equals v over pi times h. Still don't have r. So I still got to get r. Let me get r with a cool blue. Now let's go back to red, I guess. Take the square root of both sides. Take the square root of both. Now normally when you take the square root, you have to put a plus or minus. But since we're talking about radius, which is a length, you can't have a negative length. Not at least yet. So not r squared, but r, the square root of r squared is r, is equal to the square root of volume divided by pi over h. So then they tried to mess with it. They're like, okay, let's see if New York State students can read problems. We have to make this a 4-point question, so we have to find a place where we can trick kids so we can get them a point. So they said, okay, kids, the volume is 66, and the height is 3.3. So you were like smart kids. You said, okay, r is equal to the square root of 66 times pi times 3.3. I should probably put that in using parentheses. You come over to your calculator, say, okay, calculator, help me out. We're going to do the square root. Oops, that's not it. We're going to do the square root of something that's being divided, and that something is 66 divided by pi times 3.3. And you hit enter and you get 2.523 and you're like, okay, r equals 5231231, something like that. Yay, there's my answer. Round it to the near. Wait, did you read? Did you highlight the word diameter? Did you notice that they said, oh yeah, we're going to tell you about the radius, but we actually want you to find the diameter. There's the 4th point you almost missed. Remember, a radius is half the diameter. So if you really want the right answer, you have to multiply by 2 and get 5.04. So my answer is diameter is 5.04. Round to the nearest inch. My diameter is 5 inches. And there's your right answer, kids. That's it. All right, 2 left. The table below shows the attendance at a museum from 2007 to 2013. State the linear regression equation table when x equals 0 is used. So it's one of these questions. So let's talk about what this means. They're saying that x equals 0 is really 2007. So when you do your regression, you're going to put this in as 0, this in as 1, this in as 2, this in as 3. Wait a second. Almost screwed up, right? See, they're trying to get you again. See, 2007 is 0, 2008 is 1, 2009 is 2, 2010 would be 3, so 2011 would be 4. 2012 would be 5, so 2013 13 would be 6. Woo-wee! Almost messed that up, kids. Man, that would have been ugly. It would have been as ugly as me. We don't want that crap. So we'll go in here. Think. We'll call this X. Nah, probably not using X. What are these things? Year. We'll call that Y. Well, see, you got all this other stuff in there, and if you're using this calculator, make sure you have 1.1 here, but still we'll call this Y. And what is this? Attendance. We'll call this A for attendance. Got to be careful with that one though. So we're going 0, 1, 2, 4, 6. 0, 1, 2, 4, 6. Thank you, New York State, for trying to mess with me. But your teacher should have taught you that. They should have taught you that you should be careful of that. They didn't, shame on them. 8.3, 8.5, 8.5, 8.8, 9.3. Do I get them all right? 6, 9.3. 11, 4, 8.8. 2, 8.5. 1, 8.5. 0, 8.3. So it said we want to do linear regression, so we'll go into menu, statistics, stat calculations. We're going into linear regression, this one. So make sure you use number 3, because we don't want, that's the one that's mx plus b. And we're going to call, now our x values we called year, so be careful with that. Our x value is really the y, and a was attendance. This is not probably the best use of variables here. So y equals mx plus b, there it is. Now I want to write down all the decimals because I might have to round it. So m, and I like to show, and you need to show all of your work. Don't round this. 1.577, 1.577. No, 0.1577. Man, almost messed that up. It's 0.1577, 586. 586. I think as long as you have 6 or 7 decimals, you should be safe. And this is 8.269, 8.269, 827. All right, so now I say, okay, I want the linear regression model, and I round it to the nearest hundredths place. And this is what we get a lot of. 0.1. Let's see, if I round this, I get 0.1 to the hundredths, 0.16. X plus, we're going to round this to the hundredths, 8.27. Does that look like an equation to anybody? Like, seriously, is that an equation? Oh, no, it's missing a very important part. Y equals, chillin'. You have to have y equals. So there's my equation. Has to have an equal sign. It said state the correlation coefficient. So now we got to go look for the correlation coefficient to the nearest hundredth and determine if it's a strong or weak correlation. So let's go back to our calculator. Our correlation coefficient in this case is R value. This is the standard deviation, I think, and this is our correlation coefficient. So we're going to use R. R is 0.9745. So R is equal to 0.9745. So rounded to the hundredths place, R is equal to 0.97. And this is a strong linear positive correlation. And even though they don't ask for y, you should put it in there because 0.97 is very close to positive 1. Boom, done. Moving on, kids. Last problem. And then they come up with this problem, which used to be like a trig question or a pre-cal question or something like that. They said you have a rectangular picture that measures 6 inches by 8 inches. So let's do this picture. I'll draw a picture of me. That's me with hair. Oh, and it looks like I might have a unibrow now. And my huge muscles, but sort of look like zits. So, I guess they don't look like huge muscles. Anyway, there I am in all of my glory. There's your 6 by 8 picture with my hair and my unibrow and my ginormous zits for muscles. I should have been, you're right, I should have been a total artist. So now we're going to put a frame around this sucker. We're going to add a frame around this thing. Like that. And I don't want this area to exceed 100. So it has to be less than or equal to 100. Now I know this distance is 6 and I know this distance is 8. Now it also said that the frame has to be the exact same distance all around. So what we'll call this distance here is x. And of course then this is also x. And since it has to be all the way around, even though my drawing doesn't quite portray that, this is x and this is like 6x, but we're still going to call it x. So it's x all the way around. So now if I take a look at this length of this side, this length started out with 6, but we added 2 x's to it. And this length started out as 8, but we added 2 x's to it. So it says write an equation or inequality that could be used to determine the maximum width of the pieces of the frame. So in this case, my maximum would be area is equal to length times width, or in this case we want that to be less than or equal to 100. So length times width, so 2x plus 8, that's one of the lengths in width, times 2x plus 6 has to be less than or equal to 100. So that's good enough for the first part. There's my equation. My length times my width has to be less than 100. Explain how your equation or inequality models this situation. Well, I know that the total area must be less than 100. The picture is 6 inches wide plus 2 x's for the added width, and 8 inches long plus 2 x's for the added length. The product of those must be less than or equal to 100. Sorry, kids, I'm running out of room. So something to that effect. Don't copy what I wrote down there. It's something to that effect. It's kind of a silly question. It's like your picture is almost your explanation. You could almost say, hey, look up here. That's why it works. So now I've got to determine it. And this is the kicker right here. To the nearest tenth of an inch. I told you these people liked the quadratic formula and completing the square. So I got to do this to the nearest tenth of an inch, which means it's not going to be factorable. So we've got 2x plus 6 times 2x plus 8, and we need that to be less than or equal to 100. So here we go. We're going to go solve this puppy. So that gives me 4x squared plus 30, nope, jumping ahead. Plus, I'm going to do this in my head, 16x and 12x, that's plus 28x plus 48 is less than or equal to 100. Bring the 100 over, I get 4x squared plus 28x minus 52 is less than or equal to 100. Now, since these are all divisible by 4, I'm just going to take the 4 out and throw it away. X squared plus 7x minus 13 is less than or equal to 0. By the way, I brought this should be 0 because I brought the 100 over. So this is the quadratic that I'm actually going to solve. X squared minus, or is it plus? Plus 7x minus 13 is less than or equal to 0. But I'm going to solve it as if it's equal to 0. So A is 1, B is 7, C is negative 13, and D, which stands for B squared minus 4AC, So that's 49 minus 4 times 1 times negative 13. So I'm going to do that one on my calculator, but I think it's 101. So 49 minus 4 times 1 times negative 13 equals 101. So my discriminant is 101. So now I'm ready to rock and roll. X, too faint. Let's go with black. X equals negative b, so negative 7 over 2 times 1, plus or minus the square root of 101 over 2 times 1. So now I'm ready to give my two answers. So I'm going to do this. Control division, negative 7 over 2 plus the control division, the square root of 101 all over 2. Now I should get both answers. 1.524 I always like 6 decimals. Or x equals, it is a plus or minus. Now I'm just going to go up here and change this to a minus. Doesn't take long to do. And you know we're going to cancel this one because it's negative. Negative 8.524,937. 24937. You know, I take my red pen and go, can't be it. X has to equal, round to the nearest tenth of an inch, 1.5 inches. And I believe that to be correct. It is, and that's it, kids. That's all she wrote. That finishes August 2015. Thank you, Dunkin' Donuts, for keeping me awake since 4:30. I've been awake for almost like 4 hours now, kids. Bye. Hit subscribe, hit like, hit me up on the comments. Tell me how much you love the videos. Don't tell me you can't stand me. It bothers me. Hurts my feelings. Makes me want to cry.